So today we'll be starting with radio navigation. The first chapter is basic radio theory as per R.K. Bali, or just the property of radio waves. Okay, as per Oxford. Some of the definition I'll give from R.K. Bali. If there is anything extra that I'll be covering from Oxford again. Okay. So the first thing we need to discuss about electromagnetic waves. Everyone know what electromagnetic waves are? What are electromagnetic waves?
So the waves generated by electricity and magnetic properties.
Okay. Whenever there is a electric charge or electric field, it will simultaneously produce a magnetic field.
Sunil, are you trying to speak? We are not audible.
Okay, sorry, the mic was off. Okay, so I was saying we'll be doing electromagnetic waves. Um, do everyone know what electromagnetic waves are? Whenever there is an electric field present, it will simultaneously produce a magnetic field, and vice versa. Wherever there is a magnetic field, it will be producing some electric field around it. Okay, so these electric waves, while propagating, there will be a magnetic wave propagating perpendicular to it, right? If the electric field is horizontal, magnetic field will be vertical, and vice versa. So these waves, which move like with electric and magnetic properties, are called electromagnetic waves. Okay, we'll be using these waves in radio generally. Okay, so do you all know what is the frequency of wave? What is frequency?
The number of waves passing
Number of oscillations per
per second.
Yes, it is.
second.
Frequency is number of oscillations per second, or number of uh, waves passing through a point per second. Number of waves passing through a point per second. Or in physics, we would say number of oscillations per second. Okay, that is the frequency. Then, what is the another characteristics of a wave? Wavelength. You can close that. Another property is wavelength. What is the wavelength?
So the distance between the
Distance from
so I forgot what you call those.
for one cycle.
So
For one cycle of wave, how much distance it covers, right? From year to year, it is one wavelength, or from year to year, it is one wavelength, like this. Okay, it is the distance covered by a wave in unit of length, or for one complete cycle. Distance covered by a wave in a one complete cycle is called wavelength. Next is phase difference or phase. So phase difference is when you take two waves of same wavelength or same frequency, whatever is the difference between them will be the phase difference. Like if there are two waves, okay, they will be of same frequency. So any difference between them is called this phase difference. Okay, these things just basic ideas. Yes, Bhumika, any problem? Bhumika, okay. Next is polarization. So polarization is in an electromagnetic wave, two components, the electric field and magnetic field will be traveling perpendicular to each other, right? So the plane or the direction in which the electric component lies is called the direction of polarization. That will be the direction of that particular wave, and that will be the polarization of it. And you can you even have polarized glasses, right? So it will, what will this polarization do? It will only let the waves which are in the direction of the polarization to pass through, and it will block the waves which are not in the same direction, right? So that is polarization. Next is types of propulsion. There are one, two, pulse modulation, and there are three types of modulations. Okay, these things will all go through directly quickly, because these are just school things which we are supposed to know before we start into radio navigation. So we'll try to cover it quickly in brief. Next is propulsion, or types of propulsion. So there are two types. First one is continuous wave modulation. Continuous wave modulation is a continuous transmission. The transmitters and receivers use separate antennas and are capable of independent functioning. Okay. Here continuously the transmitter will be transmitting and the receiver will be receiving, and uh, they don't need each other to function. Any transmitter and any receiver will be working independent of each other. Transmitter is just transmitting. If there is any receiver, it will receive. If not, no need. Receiver will be continuously receiving. If it gets any transmitting signal, it will get it. If not, it is still functioning on its own. Okay, that is continuous wave modulation. The second one is pulse modulation. In pulse modulation, transmission is made in the form of short pulses of either amplitude modulation or frequency modulation signal or information and is carried in the form of short coded pulses. So in pulse modulation, what happens? The electromagnetic waves are modified either in their amplitude or in their frequency. Okay, these modified signals we is called a carrier signal. The carrier signal will carry this. What do you call? The carrier signal will carry the information signal with it from the transmitter, and it will give it to receiver. Okay, the modulation are of two types: the amplitude modulation and the frequency modulations. Right? You have all studied this in your schools or not?
This was not there.
11, 12.
This was not there.
There is no frequency. There was no chapter frequencies.
Yes, Japan, there
Radio
was also.
waves.
There was, but all of this was not there.
Are you serious? Which CBSE book?
CBSE.
How can it? I studied in state board. Yeah.
So they have cut
Yeah,
out, CBSE they have cut out lot of portions. So
Then what did they teach you in
it
CBSE?
was all just in the polarization and that's it.
Amplitude modulation, frequency modulation. They didn't teach you, or you did?
It was not there in the book itself.
Anyone else from CBSE? No one. ICSE or state board? Everyone.
yes, there was a chapter regarding the
Yeah,
radio wave.
I studied in.
So the polarization
That's
was
okay,
there.
okay, fine. So, okay, we'll discuss both the types of modulation. Actually, there are three types of modulation, that is amplitude, frequency, and phase modulation. Modulation means, first we'll understand what modulation means. Modulation is, designing your wave in such a way that it can be able to carry the signal with it. So, some waves will be very, what do you call, weak, but you want to transmit them to long distances. So what we'll do is we will add the power to them by modulating them by either with frequency or amplitude or phase. Okay, you'll modulate them, then they'll become strong. Then they can go to a longer distances. Okay, you'll modulation will be done depending on what kind of work they are using the waves for, right? So that is what modulation means, like modifying the signal wave with carrier waves. They'll put them together. The carrier wave will act as a transportation for the signal waves. Okay. So the three types of modulation are: first one is amplitude, in which you will modify the amplitude of a wave. So what they will do with the amplitude modulation is, so this is the first image is the signal you want to send. This is the message signal. Okay. So for that, they will have a carrier signal. So carrier signal will help to carry this message signal from transmitter to receiver. Okay. So this is your carrier signal. Okay. This carrier signal will be phased with the message signal to get a modulated signal like this, mixture of this. This is the carrier signal. This is the signal you want to send. Now this is how the message signal is sent to the through the transmitter to the receiver. Okay, they are modifying the amplitude of the carrier signal and, sorry, the message signal. Okay, message wave. So this is acting like this. Our original wave was like this. Now it is taking a carrier signal with it, and the wave is like this. That's all. Basically, just remember the diagrams, and I don't think they'll ask you any questions on this, but we'll just go through this to know. Okay, this will be your amplitude modulation. The second one is frequency modulation. Same, basically another, like in amplitude modulation, they will be modulating the wavelength of that signal. In frequency modulation, they will be modulating the frequency of that signal. Again, message signal, then this is the carrier signal. Finally, when you frequency modify it, your result will be like this. The frequency of the message signal changes. In the amplitude modulation, the wavelength of the message signal changes. Okay, they will become strong, and then they will be able to transmit it in whichever direction or forever, like more distance compared to just a message signal. Okay, and the third one is phase modulation. Phase modulation is a kind of signal modulation in which the phase of a high frequency signal or carrier wave is made to change with its amplitude in proportion to the amplitude of the input signal. This technique modulates information by changing the phase angle of the carrier signal, not its amplitude like in forward techniques. Phase modulation is very common in radio and television transmission and also in modern digital transmission because of its capability to operate efficiently in a noisy environment. So in this radio waves will be actually radio waves will be disturbed by the noises, electronic and magnetic noises, right? So this phase modulation will help us transmit signal even through noisy areas. So again, message signal. The message signal is phase modulated. You will see the resulting signal is the phase is different. Phase is when two wave signals have different phase difference between them, two different waves going around. So this is how they modify. This will be your phase modulation. Okay, these are just basic ideas. Now, important thing that you have to remember is the table of frequency bands and wavelengths. Let's see. Okay, very low frequency will be denoted VLF. The frequency range is 3 kilohertz to 30 kilohertz, and wavelength is 100 kilometer to 10 kilometer. This entire table you will have to remember. It is in the book. This is an important table. They'll ask you the frequency of any of these. They'll ask you what is the frequency of a medium frequency wave, or VHF, UHF, SHF. They'll ask you all. You should know what those frequency ranges are. Very important. Okay, write it down. Don't just nod and say okay and forget it again. This is a very important table. I just told that this table is important. Write down that you have to study the table, not write down the entire table. The table is there anyway in the book. Okay? Write down as that this is very important, or tick it in your book that it is very important that you have to study it. Okay? Okay, let's move on to next. The properties of radio waves. First property is radio waves travel at the speed of light. Radio waves travel at the speed of light, or electromagnetic waves travel at the speed of light. The speed of light is 3 into 10 to the power 8 meters per second. Okay. Second point, they get refracted, reflected, they get refracted, they get refracted. Refracted means whenever they
Bending.
pass from one medium to another medium, let's say this is air and this is water. If electromagnetic wave passes through it, it will bend. It will not continue in the same path it had entered the medium. It will bend either away or close from what it was coming. Okay, instead of being the same light, it will either get reflected this way or this way. That is called refraction. Okay, it will get refracted. Then second is deflected. Sorry, diffracted. Reflected, it will get refracted over. Second is it will get diffracted. Diffracted means whenever a beam of light passes through some small hole or something, it spreads out. When I say whenever a electromagnetic waves passes through a hole or small slit or something, it gets spread out. That is called diffraction. Like light entering sunlight entering a prism, it will diffract into seven colors, right? That is diffraction. Are you writing this? It will get refracted, diffracted. The next point is reflected. Reflected, I think you all know it will just hit and reflect back. That is reflection. And final one is attenuation. It will get attenuated. 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 Attenuated means whenever it passes through something, its energy will change. Either it will become weak or strong, mainly it will become weak. Okay, that is attenuation or attenuated. Okay, it will get reflected, refracted, deflected, diffracted, and attenuated when passing through different mediums. Okay, then third point is their direction and velocity both change. Their direction and velocity both change while passing from one medium to another or while passing through different mediums. Next is propagation of radio waves. How do these radio waves propagate? How do they travel? One second. Okay. The propagation happens in two ways. The first one is ground wave propagation. Ground waves propagation. The second one is sky waves. Yes, sky waves propagation. So I must. Okay, the radio waves travel in two ways. The first one is ground wave propagation. The second one is sky wave propagation. What does ground wave propagation means?
Will be transmitted through the on ground levels.
Yes, on the ground levels from ground to ground, it won't go to sky and get reflected back. Okay, in ground wave propagations, there is first one is direct wave or line of sight waves. So in these waves, a wave whichever is transmitted by the transmitter will be sending a straight line signals, and if there is anything in the line of sight of that transmitter, then only it will receive the signals. So if there is a transmitter here and it is sending out signals, whatever is in its line of sight, if there is a receiver there, it will receive it. If there is a receiver is not in the line of sight of this, then it will not receive the signal. Hence the name line of sight waves or direct waves propagation. Okay. And the formula to collect to calculate how much distance or where you can receive this line of sight wave is line of sight is equal to 1.23 into height of transmitter plus height of receiver, root of, okay wait I'll write it here, line of sight distance where you can receive the basic this signals are 1.23 into root of height of transmitter plus height of receiver. If you know the height of your transmitter and the height of your receiver, you will be able to calculate the distance, like how long this, till what distance you can receive this signals. Okay, and in this, second is surface waves. The surface waves follow the curvature of the earth. Okay, so whenever the surface wave, if you transmit from a transmitter, these waves will follow the curvature of the earth. like this. The direct wave or line of sight waves are usually high frequencies like VHF, UHF, SHF, very high frequency, ultra high frequency, super high frequencies. The ground surface waves are low frequencies, low frequency, very low frequency, and moderate frequency waves are surface waves. Then the third one is ground reflected wave. Third is ground reflected wave. As the name itself implies, whenever a wave which is sent by the transmitter is hits the ground and reflects back, that is, and it is received by the receiver, that is a ground reflected wave. Okay. Okay. Then fourth is duct waves. DUCT, duct waves. Third one was ground reflected duct waves. So what happens in duct waves is whenever there is a meteorological condition where this line of side waves from this first one, these waves will be traveling along the line of sight. So let's say this is the line of sight, right? But there is a temperature inversion at this layer. There is inversion. Inversion means what?
Rise of temperature with height.
With
Decrease
that.
in temperature with height. Lab rate is decrease in temperature. So whenever there is an inversion, this line of sight wave will get reflected back to the ground like this and like this. So line of sight waves is acting as a ground wave because of this atmospheric conditions. Those are called duct waves. It's like as if it's traveling through this duct. Okay, hence the name duct waves. One second. Hello. Okay. Got it?
So it gets reflected back to the ground, and again from the ground will get
Yeah, these waves keep getting reflected like this. Those are line of sight waves only, but because of the weather conditions like the temperature inversion, humidity, and all that, it will that layer will act as a barrier to it, so it will keep bouncing back and all, and it will travel along the surface. That's why though it's a line of sight wave, it will behave as if it is a ground wave or a surface wave. Okay. So, what is the relationship between frequency and static disturbance? Okay. So, what happens if the frequency is low? So, lower the frequency, higher the static disturbance. Higher static disturbance. So, whenever you turn on the radio, you get that static, like it will be continuously giving out this grrr sound, right? So, lower the frequency, higher the static disturbance, and larger antenna size. So lower the frequency, bigger the antenna you will need, and you'll need more transmission power. This This is why for the lower frequencies they will modulate the frequency or amplitude or something so that they can use smaller antenna and small less power once you modulate it, and you can send it to same distance. That's why if you're using lower waves, you can modulate it and save on the size of the antenna and the power transmission. Okay. Now we spoke about ground waves. The next is sky waves or ionosphere propagation. Sky waves. So this sky waves is whenever a transmitter transmits a message, there is ionosphere around our Earth. These lines, these waves will hit the ionosphere and reflect back. So this does not need a line of sight. But if there is an aircraft here and it is not in the line of sight, it will hit ionosphere and it will reflect. So those are sky waves. Okay, and they are going into the space, right, into the sky and bouncing against the name sky waves. So the sky waves have frequency range between 2 megahertz to 30 megahertz. So these are medium to high frequencies, high frequency range. 3 megahertz to 30 megahertz is high frequencies. Uh, these frequencies below approximately 10 megahertz. Okay. The example of sky waves are moderate frequency and high frequency waves. Okay. 1 second. Electronic density is. Okay. So the ionosphere, what happens is ionosphere is in different layers, right? It is from mesosphere all the way to exosphere, but maximum in thermosphere. So usually during daytime, due to UV radiation, what is ionosphere? Negatively charged particles. During daytime, due to the sun's light and heat, this will be supercharged and very active. But what happens in the night time is there is no UV radiation. Hence, the lower layer of the ionosphere will be discharged, and they will act as, they'll kind of disappear, you can say. So what this leads to, it kind of makes us believe that the at night the layer of ionosphere has gone up. Okay, in the daytime even the bottom ones in the ionosphere, let's say there are three layers of ionosphere, let's say. So in the daytime, all even these bottom ones are very active. So these, here it is maximum concentration, let's say, and here minimum concentration of ionosphere. Okay, in the mesosphere, the concentration is very less. So in the daytime, these will all be super active. So in the daytime, when you transmit a message, it will hit here and it will come back. But at night time, these will act as if they have disappeared. Okay, so now the waves have to travel all the way longer distance and then come back. Okay, so this gives us a feeling that at the night the ionosphere has increased in height. Okay, and this changes the travel distance of the sky waves, and that's how it will affect the propagation of radio waves, because at night time and daytime the distance traveled by the waves will be different. Okay. Okay. So So in this sky waves, whenever the sky waves are transmitted from a transmitter, they have to hit the ionosphere and come back, right? So this first point where the signals hit back is called as skip distance. Okay, the first point where the signal hits back to the ground or reaches back to the ground, that point is called skip distance. Or total distance from year to year, this is the skip distance. The space where this signal is not reaching, this is called dead space, and this total distance is called skip distance, because the wave skipped this distance. So if your receiver is here, it won't be able to receive even though the antenna is right in front of it. Okay, if let's say receiver is here somewhere, it won't receive, here somewhere it won't receive, here it won't receive, because the wave is here, it is traveling towards the sky and it backs some point here. So this total distance is skip distance. This space where the wave can't be received even though antenna is right in front of us, that space is called dead space. Okay, this is first wave meeting, this will be your skip distance, and this will be your dead space. The angle between the normal to the waves transmitted is called angle of incidence. This will be angle of incidence. If you draw a straight line or the normal line to the antenna, to the waves direction of the waves, that is called your angle of incidence. And the angle between the normal to the first wave which reflects back to the earth, that is called critical angle. Okay, any doubts till now? Am I going fast? You want me to?
Uh, Captain, I couldn't hear when you told critical angle. Can you tell once again?
Sorry.
I couldn't hear when you told critical angle.
Okay. So whenever you are transmitting the waves from a antenna, you draw a normal line to antenna. The angle between that normal line to the waves is angle of incidence. Okay. Critical angle is, so not all the waves come back. The first few waves will get reflected and exit out. At one point, it will hit and reflect back. Okay, that is the first wave which hits and reflects back to the earth. The angle between that wave and to the normal is called your critical angle. Okay.
Oh, yeah, understood.
Okay. Now, since this waves are traveling to the ionosphere and reflecting back, they'll get a little disturbance in them. Obviously, right? Atmosphere it is getting, it is all throughout, it is traveling and coming back. So there will be disturbances in it. So this disturbances which are received by the receiver but not transmitted by the transmitter is called fading. Fading is due to the disturbance created by the waves. Some variations can be seen in the signal strength at the receiver end. This is known as fading effect. Okay, whenever you transmit something, because the all radio waves can get reflected, refracted, diffracted, and all that, right? Attenuated. So because of that, by the time the receiver receives it, there will be a change in its strength. That change in its strength is called fading. Okay. So higher the frequency in a sky waves, higher the fading effect. More higher the frequency in the sky waves, higher will be your fading effect. Okay. Now what happens is, as I was saying, in the night, the ionosphere layer will go up. So let's say this is daytime. And this is night time. Okay. What is happening?
It has to, during night time, we have to travel.
It has to travel further higher, so it will reach further away from where it was reaching in the daytime. So now, even the aircraft daytime, if it was here, it was receiving the signal. Now in the night time, it is not receiving the signal. Now it is in dead space. So the dead space increases in the night time. So if during night the frequencies will have to be set accurately, then they will have to be brought back here so that they will reflect back. Okay, this has to be done if you want to keep receiving the signals in the same places again. Okay, this is the night effect of radio waves. Okay, radio waves will get affected by the day and night time also. Okay, now let's just summarize the propagation. Actually, there is one more thing. So propagation was ground waves and sky waves. The ground waves are furtherly, which ones? Direct or line of sight. Ground waves or surface waves.
Ground reflected waves.
Ground reflected
Dark waves.
and dark waves. Correct? In sky waves, it will be sky waves only, and sorry, sky waves, or you can take it as ionospheric propagation. Sky waves, and there is one more, that is satellite waves or SATCOM, satellite communication direct wave. So satellite communication waves are again direct waves. What will the transmitter do? The transmitter will transmitter will send a signal to a satellite. Satellite will in turn send signal to a receiver. This is all through direct wave or line of sight. But it is going into ionosphere where the satellite is and reflecting back, coming back to the satellites. So this is also ionospheric propagation, but these are again direct waves or line of sight waves. Okay.
Captain, I can't read that one word. Like satellite.
Satellite com direct wave. Sat com or satellite communication direct wave.
Okay.
Okay, these are the different types of radio waves. One second. Okay. Then I'll have to refer the Oxford one first. I'll give a basic idea of antennas. Okay. Um, Antennas are also called aerials. AERIALS. Okay. Antennas or aerials are the means by which radio energy is radiated and received. Okay, always you have seen, everyone has seen antennas. Different device will have different kind of antennas, right? Spiral antennas, straight antennas, circular antennas, all those. Okay. The basic principle, there are two basic types of aerials used for receiving and transmitting basic communications: the half wave dipole and the Marconi or quarter wave aerial. One second. So half wave dipole is, there are two types. One is half wave dipole and the first one is, second one is half wave dipole and second one is Marconi or quarter wave dipole. Then the only difference is in half wave dipole, the length of or height of the antenna will be half of the wavelength. Okay, the height of the antenna half of the wavelength. Whatever the waves it is, what is the wavelength? The antenna will be half of it. In Marconi or dipole, it will be quarter of it. The height of the antenna will be the quarter of the wavelength of the waves we want to transmit. Basically, the Marconi aerials are generally being used on the aircrafts. Okay, so what happens is in the Marconi aircraft antennas. Uh, on the aircraft they'll put this antenna. This will every antenna needs two poles, and they are called dipoles, right? It should have two poles. So this Marconi antenna is one pole, and it will be attached to a metal surface, right? This metal surface will act as another pole. That's how it will work as two pole, and it will be able to work with only quarter of the height of the wavelength. But whereas if you are using half wave, you will need to have two poles. Then you will need to have one straight antenna and one circular antenna or something like that. Okay. If you have seen these old TV antennas, they used to be like this, uh, and they will be like this, right? So that's why they are dipoles. So there are two different, one on top, one on bottom, or one straight and one circular, all those things. But now in aircraft we use this Marconi, which is just one straight antenna. Okay, that is half of, sorry, quarter of the wavelength, whatever the waves you wanna send, and the aircraft metal body itself acts as the another pole, hence dipole. Okay. This is not even covered in the RK Bali. These are not their antennas and all, but I'll just give you basic information of all this before we jump into the radio instruments. That's why I'm looking at both the books. I'm like, there is some information in RK Bali and some in Oxford.
Captain, where is this written in Oxford?
There is an entire chapter called antennas, chapter 4.
Oh, okay.
Okay, you don't have to go through all that. This Oxford is EASS syllabus and ATPL book. You don't have to go through all that. That's why I'm just giving you some of the information which is only needed for you. I have never been asked the question on antenna even in ATPL, so don't worry. But these things, basic ideas, you have to know that if we use Marconi antennas in the aircraft, wavelength will be quarter of it, height will be quarter of the wavelength and all that. But the first things, there was one formula which I had given, line of sight equal to 1.23 into root of height of transmitter into height of receiver plus height of receiver. That question will come. They'll give you the height of transmitter, height of receiver. They'll ask you to find at till what distance you can get the signal. Okay, all you got to do is put the values directly. Signal distance is equal to 1.23 into root of, in the bracket, root of height of transmitter they would have given, just put that height, plus root of, they'll give you the height of receiver, just put that height, you'll get the final answer. Okay. Okay, okay, so this is all about basic radio theory, which you needed to know. From now, after this, we'll have to start with the instruments, like the what all radio instruments we use. That I'll be starting tomorrow. We'll finish the radio theory here. From tomorrow, we'll start with this ADF and NDB. Let me see how it is running. EDF and DVR. EDF, VDF, POR. Okay. Yeah, we'll start tomorrow on the radio instruments and some numericals also. I think uh, will come after some numericals also. That also we will solve. Three, four,
Is this tomorrow a Saturday holiday or
Oh yeah, I think it's gonna be a holiday. I'll just confirm once with the Pune team and I'll let you know. Mainly, it's gonna be a holiday. Even if it is not a holiday, I won't be coming. So I think they will declare a holiday. Any questions till now? So
No, Captain.
important things from today's class is just read the definitions. Then read the definition for your understanding. Read that formula which I gave, and also the frequency ranges I told you, right? VHF, VLHF, and just understand what this reflection, night attenuation all does, because that will come through in every instrument now. Which instrument will face what kind of errors or problems. Okay, in daytime, nighttime it will lead to attenuation, and we are the if we are getting some waves reflected from the earth, we might get the wrong readings in view or all those things. So we'll be reading all through each and every instrument. So if you have a basic idea of what is happening in those, then you will be able to understand those. Okay, that's all. Any questions?
No, Captain.
No, Sunil.
Okay, fine. Thank
Okay.
you. See you, everyone, and happy Raksha Bandhan to everyone.
Thank you, Captain. Same to you.
See you, Captain. Bye-bye.
Thank you.
Okay, thank you. Bye.